Welcome to Brain Vision.
M is equal to 3.34 times 10 to the power minus 27 kilogram, and charge Q is equal to plus E. Well, the deuteron travels in a circular path with a radius R, which is equal to 6.96 millimeter, 6.96 millimeter in a magnetic field. So it travels in a circular path in a magnetic field whose magnitude is equal to 2.50 Tesla. Well, let's do part A. Well, we know that magnetic force is given by Q into V cross B. That's the magnetic force. Well, the angle between the magnetic field and the velocity is 90 degrees, and therefore magnitude of magnetic force is equal to Q times V times B. Let's call this equation number 1, since sine of 90 degrees is equal to 1. Okay. The magnitude of the force must be equal to the force given by Newton's second law. Well, Newton's second law says that F is equal to ma, right? Here, A is the acceleration, which is directed radially inward. The radial acceleration is given by v squared divided by r, that's radial acceleration. And therefore, magnetic force is equal to m times v squared divided by r. Let this be equation number 2. Now, combining equation number 1 and equation number 2, we have QVB is equal to mv squared divided by r. And from here, V is equal to Q times B times R divided by M, right? Now, by doing substitution in this equation, V is equal to 8.35 times 10 to the power 5 meter per second, right? So V becomes 8.35 times 10 to the power 5 meter per second. Now let's do part B. Well, we know that the acceleration A changes the direction of the velocity, not its magnitude. The deuteron moves with a speed of v for a distance of d, which is equal to the circumference of the semicircular path, which is pi times r. Well, the time of this displacement equals the distance divided by velocity. That is, t is equal to d divided by v. Here d is pi times r. And then we have a speed in the denominator. Let's plug in values. Pi into 6.96 times 10 to the power minus 3 meter divided by 8.35 multiplied by 10 to the power 5 meter per second. So we have time t is equal to 2.62 times 10 to the power minus 8 seconds. Now let's do part C. Well, we need to find out the potential difference would the deuteron have to be accelerated to acquire this speed, and the kinetic energy must be equal to the potential energy. So we have half mv squared is equal to q times v. V is the potential difference, right? And from here, v is equal to m times v squared divided by 2 times the magnitude of charge, and by doing substitution, v is equal to 7.27 multiplied by 10 to the power 3 volt.